Today we are doing lesson 2.4, dividing rational numbers. Our I can statements for today: I can divide rational numbers and I can solve real life problems. So I want to start by just taking a look at a couple models to help us visualize what dividing with positive rational numbers means. So here I have a square with 100 little squares here. In each column, in each row, there are 10, so they represent tenths. So the problem 6/10 divided by 3/10, what that means is how many groups of 3/10 are in 6/10. So you have to look to see how many groups we have. So I have 1, 2, 3, 4, 5, 6 columns of 10, so that's our 6/10. And then one group of 3/10, another group of 3/10. So 6/10 divided by 3/10 is going to equal 2. It's not 2/10. How many groups are there? 2. Now, if you look at this and you move the decimal the same amount of places on each number, I moved it once on each, the answer remains the same. 6 divided by 3 equals 2. And if you think about that as a fraction, like writing it in fraction form, 6/10 divided by 3/10, that moving that decimal is really like multiplying both sides by 10. And if you multiply on a fraction, the top and the bottom, by the same number, the relationship stays the same. Because when you're multiplying by 10 on the top and multiplying by 10 on the bottom, and then you're dividing it, our answer stays the same. The relationship is the same. So we need to make sure when we see decimals that we move those decimals over the same amount of places so that that second number is a whole number. Once you have that to be a whole number, then you can do your division. And really it could be a whole number or an integer, because that second number can be a positive number or a negative number. Okay, let's take a look at one with fractions. So here I have 2 circles split up into thirds, and my division problem is 2 divided by 1/3. And that means how many groups of 1/3 are in 2 wholes. So I have my first circle split into thirds, my second circle split into thirds. How many are there? 1, 2, 3, 4, 5, 6. There are 6. Okay, so if you look at that picture, when I'm splitting our 2 circles into 3 pieces, it's really like I'm doing 2 groups of 3, like 2 times 3, because I've got 3 on the first one and 3 on the second one. So 2 divided by 1/3 ends up being the same thing as 2 times 3. I'm going to rewrite it down here. 2 divided by 1/3 equals 6. And that means the same thing as 2 times 3 equals 6. So how do you get from that first problem to the second problem? We do something called keep, change, flip. That first number, we keep it the same. The operation sign we change, kind of like when we do our boom booms, we change 2 things. Same thing with keep, change, flip. We change that division into multiplication. But in order for the relationship to stay the same, this 1/3, we have to flip it. So instead of 1/3, it becomes 3 over 1. So 2, which is like 2 over 1, times 3 over 1 equals 6 over 1. We did keep, change, flip, and then we could multiply straight across. All right, let's look at this last one. So 3 divided by 2/3. So this one's a little trickier. So we're looking for how many groups of 2/3 are in 3 wholes. So I have 1, 2, 3 big rectangles, and they're each split into thirds. Okay, so let's see how many groups. I have 1, 2, 3, 4 groups that each have 2 little bars in them. 1, 2 for your first, 1, 2 for your second, 1, 2, 1, 2. And then I have only 1 left over. That's half of a group, because one group has 2 little parts to it. It's a third of the whole rectangle, but it's a half of the 2/3 group. So what is my answer on this one? Well, I can do that 2/3 into 3 4 times with a half of a group left over. Let's look at how we would do that without the picture. So if I'm going to use that keep, change, flip strategy, I would have 3 over 1. That division becomes multiplication. And then I flip over that 2/3. Keep, change, flip. Notice how I took my 3 and I wrote it as an improper fraction, 3 over 1. That's because when we have mixed numbers or we have whole numbers being multiplied by fractions, we need to make sure it's written as a fraction with 2 parts. 3 times 3 is 9. We're multiplying straight across. 1 times 2 is 2. 9 halves. 2 goes into 9 4 times, with 1 as a remainder. So 4 1/2. That's how I could get that answer without the picture. All right, so let's go ahead and take a look at a couple examples here. So dividing with rational numbers. So we're using those same rules that we learned when we were doing the integers. If we have the same sign, your answer is going to be positive. When you have different signs, your answer is going to be negative. And then otherwise, we are using our rules for division with fractions or division with decimals that you learned when last year in 6th grade. So here's our problem. We've got -10 and 35/100 divided by -2 and 3/10 equals a positive 4 1/2. When we write out this problem, we would want to make sure we move our decimals one place over, make that into a -23. And this first one we would change into a 103.5. Doesn't really matter if the first number has a decimal, but the second one cannot have a decimal when we set up the long division. And then here, 5 divided by 2/8 equals 20. If we do keep, change, flip, multiply straight across and simplify, we would get a positive 20. Different signs negative, so 1 and 3/10 divided by -10 and 3/10. That is going to give you a negative answer. Different signs, same thing here. Different signs on these problems, so our answer is going to be negative. All right, and then for a vocabulary word here is complex fraction. And this probably is something that is new or strange looking to you. Complex fraction is a fraction that has a fraction in its numerator, the top, the denominator, or both. It's a different way of writing division when you have fraction parts. 3/5 divided by 1/2. It's just a different way of writing 3/5 divided by 1/2. That numerator comes first in the problem if you're going to write it out horizontally. The denominator is the one that'll end up getting flipped. Okay, so let's try a couple problems together. So for this first one, I have 8 divided by -4/3. So my first step, I need to write that 8 as an improper fraction, 8 over 1. Then I'm going to do keep, change, flip. So 8 over 1, so that's the keep. Change that division sign is changing to multiplication. And then flip that -4/3, I'm going to change to -3/4. Now I can keep the negative out front like it is here, but I always just like to write my negative in the numerator. Doesn't have to stay with the 4. Could, but it doesn't have to. I always write mine on the top. So keep, change, flip. That 4/3 flips to become -3/4. Okay, so all right, so now we are ready to multiply straight across. Some people like to cross cancel. You certainly can. You don't have to. So 8 over 1 times -3 over 4. I'll do it both ways. So I'll multiply straight across first. 8 times 3 is 24. Different signs, answers, negative. So -24. 1 times 4 is 4. -24 divided by 4. That goes in evenly. It's a -6. Now, I said you can cross cancel if you want. You would do this way. 8 and 4 can both be divided by 4. 4 divided by 4 is 1. And 8 divided by 4 is 2. Then you could do 2 times -3 to get your -6. All right, so in this next one, we have a complex fraction. It means the same thing as this division sign, negative 2/3 divided by negative 5/6. Okay, so I'm going to do negative 2/3 divided by negative 5/6. All right, we're going to do keep, change, flip. So keep the first one the same, negative 2/3 times, so we're changing, and then flip. So instead of negative 5/6, I'm going to write negative 6/5. I'm keeping that negative sign on the top. Now I have same sign, so answer is going to be a positive number. I can cross cancel if I want, or I can multiply straight across. I'll show you both ways. So multiplying straight across, negative 2 times negative 6, that would be a positive 12. 3 times 5 is 15. Both 12 and 15 are evenly divisible by 3. So 12 divided by 3 is 4. 15 divided by 3 is 5. So my final answer here is 4/5. If I wanted to cross cancel, the numbers that cross cancel are 6 and 3. They're both divisible by 3. 3 divided by 3 is 1. Negative 6 divided by 3 is negative 2. And then we do negative 2 times negative 2 is 4, and 1 times 5 is 5. All right, it does say up here, write your answer in simplest form. I didn't read that direction to you, but that should be a given anytime you're working with fractions. Your answer needs to be fully simplified. All right, and then let's look at this word problem. A water pail in your backyard has a small hole in it. You notice that it is drained a total of 2.5 liters in 5 days. What is the average change in water volume each day? Okay, so this is our rate here. This is our order. We're going to do 2.5, and we're going to divide it by the 5 days to figure out what the average change is. On this one, I actually don't need to move my decimals because my second number is already an integer. Okay, so I have 5 does not go into 2. I'm putting a 0 in a decimal. 5 does go into 25. It goes in 5 times. 5 times 5 is 25. Oops, I wrote a decimal in there. I didn't really need to do that. Okay, so that gives me 0. So what is the average change? Okay. So I'll write it drained 5/10 liters per day. This is a rate because there's 2 labels there. So here I chose to use the word drained, but it's drained means going down, so I could have also, instead of using the word drained, I could have also said that's a negative 5/10, because really this 2.5 is really like a negative. It's going down. All right. Let's take a look at our next problem. Here we've got mixed numbers. Just like with multiplication and mixed numbers, your first step on these problems is to take those mixed numbers and rewrite them as improper fractions. Okay, so find negative 5 1/5 divided by 2 1/3. All right, so 5 times 5 is 25 plus 1 is 26. I'm going to write the negative in the numerator. Negative 26/5. I'm going to keep it as division. It's too much, in my opinion, to do the keep, change, flip and the improper fraction in the same step. It's really easy to get your numbers mixed up there. So I recommend doing those in 2 separate steps. Okay, so 3 times 2 is 6, plus 1 is 7. So negative 26/5 divided by 7/3. Okay, now I'm ready to do my keep, change, flip. So negative 26/5 is going to keep. It's going to be the same. I'm going to change it to multiplication, and then I'm going to flip that last fraction. So instead of 7/3, I now have 3/7. All right, so now I am ready to multiply straight across. I don't see anything that I can cross cancel here. Negative 26 times 3, that's kind of a big number to do in your head. So I'm just going to do it over to the side just to double check. Now if you think 25 times 3 and then add 3 to it, that'll give you that same answer. 6 times 3, that would be 18. 3 times 2 is 6, plus 1 is 7. Different signs, answer is negative. So my numerator is negative 78. And then 5 times 7 is 35. Okay, so now I need to pick that and put it back into a mixed number. Again, my numbers are kind of big, so it might be a good idea to go ahead and just write out the division off to the side. 78 divided by 35. You might have to do some guessing here, guessing and checking, because our numbers are kind of big. I know 35 goes into 78 2 times, and that 2 times 35 is 70. And 78 minus 70 is 8. And these were different signs, so my answer is negative. Negative 2 and 8 35ths. 8 and 35 do not have any common factors, so I can't simplify them anymore. So that is my answer right there, negative 2 and 8 35ths. All right, let's take a look at this next one. So I'm going to divide. I have negative 36 hundredths divided by negative 9 tenths. I'm going to move my decimal over once because my second number here has 1 decimal. And I want to make that number into a whole number or an integer. So here's my new problem. I move my decimal over once. I have 3 6/10 divided by negative 9. Doesn't matter that there's a decimal in the first problem. What matters is the second number. Okay, so now I'm going to set my division. The first number goes on the inside, 3 6/10. The second number goes on the outside, negative 9. I know my signs are different, so my answer is going to be negative. I'm going to go ahead and put it up there where my answer is going to be. 9 does not go into 3 a whole number of times, so I'm going to put in 0. I'm going to bring that decimal straight up. 9 goes into 36 4 times. 4 times 9 is 36. 36 minus 36 is 0. So I'm done. My answer for this problem is negative 4/10. I'll rewrite it over here so it's just a little bit easier to see. All right, here are 3 problems to try on your own. Go ahead and pause the video and try them on your own. Okay, let's check our answers. So for the first one, I have negative 6/5 divided by negative 1/2. It originally was written as a complex fraction, but that's what it means. Negative 6/5 divided by negative 1/2. Okay, now I'm going to do keep, change, flip. So keep negative 6/5. Change that division to multiplication. Flip that negative 1/2 becomes negative 2 over 1. Same signs, answer is going to be positive. I'm going to multiply straight across. 6 times 2 is 12. 5 times 1 is 5. 5 goes into 12 2 times, with 2 as a remainder. So my final answer is going to be a positive 2 2/5. Let's look at this next one. My first step is going to be taking that mixed number and changing it into an improper fraction. 1/3 divided by 3 times 2 is 6, plus 2 is 8, so that's going to be negative 8/3. Keep, change, flip. 1/3 times, then I flip here, negative 3 over 8. I'm keeping that negative in the numerator just to keep myself organized. Nothing to cross cancel on this one. We're going to just multiply straight across. 1 times negative 3 is negative 3. Different signs, answer is negative. 3 3 times 8 is 24. Actually, I was wrong when I said there's nothing to cross cancel. I'll go back and show you. Because here I do need to simplify, so I could have cross canceled in the first place. I just didn't see it right away. Negative 3 divided by 3 is negative 1. 24 divided by 3 is 8. So I have negative 1/8 as my answer here. Here I could have done 3 divided by 3 is 1. And 3 divided by 3 is 1, really a negative 1, because that's negative. Then I could have done 1 times negative 1 is negative 1, and 1 times 8 is 8. All right, let's take a look at number 3. Both of these numbers have 1 decimal. I need to move that decimal over. My new problem that I'm going to set up is negative 54 divided by 12. The first number goes on the inside, 54, negative 54. The second number goes on the outside. Different signs, answers negative. I'm going to go ahead and put my negative up there by my answer. 12 does not go into 5. It does go into 54. It goes in 4 times. 4 times 12 is 48. Okay, we're going to subtract 4 minus 8. Takes me into the negative, so I'm going to borrow. That will be a 4. This will be a 14. 14 minus 8 is 6. 4 minus 4 is 0. Because this is a decimal problem, I don't want to say negative 4 and 6/12. I started with decimals. I need to end with decimals. So I'm going to add a 0 and a decimal. So decimal after the 4, decimal after the 54. Add a 0, bring it down. 12 goes into 60 5 times, and 5 times 12 is 60. I'm ending here in a 0, so that means I'm done. My answer is negative 4 and 5/10. Okay, here are 3 more problems to try on your own. Pause the video and try them. Okay, so let's go ahead and check out our answers. So first thing we need to do here is make both of these into improper fractions. 7 times 2 is 14. Plus 4 is 18. So I have negative 18 sevenths divided by, and then negative 3, I'm just going to put a 1 underneath it. Negative 3 over 1. Now I'm ready to keep, change, flip. So keep the negative 18 over 7. Change to multiplication. Flip negative 1/3. Okay. I can cross cancel if I want, or I can multiply all the way across. I think on this one I'm just going to go ahead and cross cancel before I start. Negative 18 divided by 3 is negative 6. 3 divided by 3 is 1. Negative 6 times negative 1 is positive 6. Same sign, answer is positive for multiplication and division. 7 times 1 is 7. So a positive 6/7 is my answer. All right, next one, negative 9 and 6/10 divided by 8. My second number is already an integer. I do not need to move decimals on this one. Negative 9 and 6/10 goes on the inside. 8 goes on the outside. Different signs, answer is negative, so I'm going to go ahead and put my negative sign up here. 8 goes into 9 once. 1 times 8 is 8. I subtract 9 minus 8, and I get 1. I'm going to bring up that decimal point. I'm going to bring down the 6. 8 goes into 16 twice. 2 times 8 is 16. I have 0 as a remainder, which means I am done with my problem. Negative 1 and 2/10. All right, and then number 6, 6 and 45/100 divided by negative 30. Again, my second number is an integer. I do not need to move decimals. 6 and 45/100 divided by negative 30. Different signs, answers negative. I'm going to go ahead and put my negative sign up here. All right, 30 does not go into 6 a whole number of times. So I'm going to put my 0, and then I'm going to bring up the decimal point. 30 does go into 64. It goes in twice. 2 times 30 is 60. 64 minus 60 is 4. Bring down that 5. Okay, 30 goes into 45 once. 1 times 30 is 30. 5 minus 0 is 5. 4 minus 3 is 1. Okay, I still have a remainder even though I've run out of my numbers. So that means I just need to add a 0. Bring it down. I got to keep going to either I have a remainder of 0 or I have a pattern. So 30 goes into 150 5 times. 5 times 30 is 150. 150 divided by 150 is 0. Okay, so I'm done. My answer is negative 215 thousandths. Okay, for this one we have a story problem. It says an investor owns stocks A, B, and C. What is the mean change in the value of the stocks? Mean change. Mean means you add the numbers and you divide by the number of numbers. Okay, so that's what we're going to do. We are looking at the changes. So even though there's a bunch of information in this account picture, we're really just looking at the mean of the change numbers. We've got some red ones that are negatives. That means the current value, it went down. And then we have one that's positive, which means the value went up. Okay, so the first thing we need to do is add our list of 3 numbers. Now we can do them just in a row. We can group together the negatives. I think I'm just going to keep them, let me think. Actually, no, we'll add our 2 negatives together. I'm going to put the number with the greater absolute value on the top, 280.52 cents. That's a negative. And a negative 180.39. Same signs, find the sum. 2 plus 9 is 11. 1 plus 5 is 6, plus 3 is 9. 0 plus 0 is 0. 8 plus 8 is 16. 1 plus 2 is 3, plus 1 is 4. These were 2 negatives. My answer is negative. Remember, same sign, positive. That only works for multiplication and division. Okay, so I got rid of this one, and I got rid of this one. I still have this one left. So now I'm going to write my next problem, negative $460.91. Greater absolute value goes on the top, plus a positive $127.28. We did same signs, find the sum. Now we're going to do different signs, find the difference. 1 minus 8 takes us into the negatives. We're going to borrow. That 9 will become an 8. This 1 will become an 11. 11 minus 8 is 3. 8 minus 2 is 6. Bring down that decimal point. 0 minus 7 takes us into the negative. So we're going to borrow 1 from here. That 6 becomes a 5, and that 0 becomes a 10. 10 minus 7 is 3. 5 minus 2 is 3. 4 minus 1 is 3. More negatives, answer is negative. All right, we're not done yet. That's just the total change. That's not the mean change. We added our numbers. Now we need to divide by the number of numbers. We had 3 numbers. I've now used all 3. We got that as a total. Because we had 3 numbers, that means we need to divide by 3. So I'm going to go ahead and set up my division. That's what I'm doing right here. So negative $333.63 divided by 3. Okay. 3 goes into 3 once. 3 minus 3, 0. Bring down my 3. 3 goes into 3 once. Got 3, 0. Bringing down my 3. 3 goes into 3 once. 3. I'm going to extend my page here a little bit. Oof. Okay. Got a 0. Got to bring up my decimal. Bring down that 6. 3 goes into 6 2 times. 2 times 3 is 6. And then my last digit here is 3. Goes in once. 1 times 3 is 3. Got a 0. I used all my numbers. Different signs, answer is negative. So my final answer, the mean average, is a negative $111.21. All right, for our last one here, it says, what if the change in value of stock D is $568.23? What is the mean change of value of the 4 stocks? So I'm going to get it set up for you, and then I'll have you try it on your own. So we have here $568.23 that we need to add to our total from the last one, which was at negative $333.63. I think that was the right number. Let's double check. Yep, that was our total here, $333.63. We're going to add those two together. And then because we have 4 stocks, once we add our values together, we're going to take that answer and divide by 4. Okay, so you need to add these two together to find the total change. And then to find the mean, you're going to divide by all 4. So go ahead and pause the video and finish this problem on your own. Okay, let's check to see if you did it correctly. Different signs, we're going to find the difference here. 3 minus 3 is 0. 2 minus 6 takes us to the negative, so we're going to borrow. That 8 becomes a 7. The 2 becomes a 12. 12 minus 6 is 6. Bring down the decimal. 7 minus 3 is 4. 6 minus 3 is 3. 5 minus 3 is 4. Don't know what I'm saying there. 5 minus 3 is 2. More positives. Answer is positive. Okay, but I need to divide by 4. So I'm going to take my $234.60, divide it by 4. 4 does not go into 2 a whole number of times. 4 does go into 23. It goes in 5 times. 5 times 4 is 20. 23 minus 20 is 3. Bring down that 4. 4 goes into 34 8 times. 8 times 4 is 32. 34 minus 32 is 2. We're going to bring that decimal straight up. I'm going to bring the 6 down. 4 goes into 26 6 times. 6 times 4 is 24. Okay, 26 minus 24 is 2. Bring down that last number. 5 times 4 is 20. We've got 0. Story problems always need a label. Got $58.65. Now I don't remember if I put a label on my last one, so I'm going to go back just to double check. Oh, good, I did. I have dollars here as well. Story problems always need a label. Okay, so our final answer for problem 7 is $58.65.